Well, thank you for joining us here today.
Pleasure.
You've written a book.
One or two.
Congratulations on that.
Thank you.
In fact, you've been an AI researcher and author and a teacher for a long time. You've seen the field of AI sort of graduate from a niche field that academics were working in to a global priority in private industry. But I was a little surprised by the thesis of your book. Do you really think that the current approach to AI is sort of fundamentally mistaken?
So let me take you back a bit to even before I started doing AI. So Alan Turing, who, as you all know, is the father of computer science, that's why we're here. He wrote a very famous paper in 1950 called Computing Machinery in the Mind, and that's where the Turing test comes from. He laid out a lot of the different subfields of AI. He proposed that we would need to use machine learning to create sufficiently intelligent programs, and so on. And what most people may not know is that the following year, 1951, he gave several public lectures in which he said, oh, and by the way, and here, this is the quote, we should have to expect the machines to take control. So that was right there at the beginning. So it's not a new thing. And if you think about it, right, imagine you're a gorilla or a chimpanzee, right? How do you feel right now about these humans, right? They came along, they're smarter, they have bigger brains, and my species is toast, right? So if you just think of it that way from a common sense point of view, you have to wonder, well, why are we doing this at all? Have we thought about what happens when we succeed in creating the AI that we all sort of dream of, right? And Turing was completely unequivocal. We lose. So what the book is about is why would we lose, and is it inevitable? And if it's not inevitable, how do we avoid losing? So I want to change that kind of mindset that I think a lot of people assume that, you make AI better, you win. No, you make AI better, you lose. That's the default condition. And we have to change that by taking some concrete steps. So to understand why is it that better AI produces worse outcomes? And the answer seems to be that we've actually thought about AI the wrong way from the beginning. And in the book, I call this the standard model, which is a phrase borrowed from physics, right? So they have the standard model of the forces and their unification and so on. And everyone kind of buys into that, and then you nibble around the edges of it, trying to fix up various things. So the standard model of AI is that we basically borrowed it from the idea of intelligence that was prevalent in the 40s and 50s from economics and philosophy, namely the rational agent, the entity that has an objective and then acts so as to achieve the objective. And so the natural thing to do was to say, okay, well, machines are intelligent if they act to achieve their objectives. But of course, they don't have objectives, so we have to plug them in. So that became the standard model. You build optimizing machinery, and you plug in an objective, and off it goes.
And the objective being something like make me a coffee,
yeah, it could be fetch me a cup of coffee, or change the carbon dioxide levels in the atmosphere back to their pre-industrial levels, or get people to spend more time glued to their cell phones. And the problem is that, and this is not something that should come as a big surprise to anyone, the problem is we don't know how to specify the objectives completely and correctly. And we've known this for thousands of years, right? I mean, if you go back and look at any story where the gods or the genie gives you some wishes, you invariably get it wrong. And your third wish is, please undo the first two wishes.
Yeah, let's go back to the first
one.
Because
I completely ruined the world,
yes.
Right? And the King Midas.
Exactly.
And his wish, he got exactly what he asked for, and then his food and his drink and his family all turn to gold, and he dies. So we know this. And people started to point out around 2000, people like Eliezer Yudkowsky, Steve Omohundro, that as AI systems become more and more capable, right, if they're pursuing a fixed objective that's wrong, the more capable the AI, the worse the outcome, because they will effectively use the rest of the world that isn't mentioned in the objective in order to get a better result on the objective, to increase the degree of success, to reduce the probability of failure, including, failure by being switched off, right? So a machine that has an objective, like fetch the coffee, if it's sufficiently intelligent, would realize, if someone switches me off, I will fail to fetch the coffee. Therefore, I have to defend myself. In fact, I have to take preemptive steps against any other entity that might switch me off, because I want to reduce that probability of failure as low as possible. So you get these sort of pathological behaviors, and they're simply a consequence of more and more capable AI pursuing an incorrectly defined objective.
Right,
so,
through the standard model, rather than just because we don't have the priorities correct. We don't have the way to specify the objective.
Yeah, and it's not, I would say it's not just AI, right? This is control theory, where you minimize a cost function. Operations research, you maximize a discounted sum of rewards. In statistics, you minimize a loss function. In economics, right, you maximize a welfare function, or you maximize discounted quarterly profits. And so this is actually, when you think about it, a big part of the intellectual output of the 20th century. And it only works when your machines are really stupid, right?
Because they don't have a chance to do something really bad.
Right, if they're not smart enough to sort of think about how to change the rest of the world. But we're already seeing, so if you think about corporations as machines that maximize quarterly profits, they're getting smarter, right? And they're actually destroying the world. And whether you like it or not, the rest of the human race has lost that particular chess match.
There's a plot twist. The AI was here all along, and it was Exxon.
It was Exxon, yeah, exactly.
But unlike you said that this has been a problem people have recognized for some time, although many researchers have taken advantage of the standard model to accomplish various practical tasks. So not everybody agrees with you on this. They think that perhaps this is not as much of a threat as you suggest it is. Do you have a response for that? Are they just in denial, or do they have a point?
I think denial is probably the right word, because what you see, is very intelligent, respectable people making arguments that, with all due respect, a 5-year-old could see through. Right. So, for example,
are any of them here in this audience?
Any of the 5-year-olds? Yeah. Right. So, one argument being, well, electronic calculators are superhuman at arithmetic, and they didn't take over the world. Therefore, there's nothing to worry about. Another one of my favorites was, well, yes, it is theoretically possible that a black hole could materialize in near-Earth orbit and suck the Earth into it. But we don't spend a lot of time worrying about that, so why should we worry about superintelligent AI? And I'm sure those of you who are in denial will say, oh yeah, that's a good argument, right? But if the entire physics community and the big chunks of government budgets around the world and all of the top 10 largest corporations in the world were investing all of their resources in making black holes materialize in near-Earth orbit, wouldn't you ask them if that was a good idea?
Yeah, excuse me. Yeah.
And so, and I could go on and on. I used to give talks where I would go through all of the counter arguments and then the refutations of those arguments.
Well, you do in the book as well.
Yeah, and I do in the book because I have time. But I ran out of time. I got up to like 33 ridiculous arguments, and I realized I was taking up 2/3 of my talk with refuting these things.
Maybe the next book.
And so. I think there's also an unwillingness to really exercise the imagination about what would it really be like to have smart machines. And if you want to see what it's like when machines get out of the lab, right? So we actually had two things going in our favor. Number one, the machines are really stupid. Number two, they were confined to the lab. And often even they were confined to a simulation in the lab. But they are now out in the real world. So the algorithms that determine what billions of people spend hours a day seeing, reading, listening to, those algorithms are learning algorithms, and they are optimizing an objective of engagement or click-through.
And we saw how that went.
We can see how that went, right? And not only that, we can't turn them off.
Yes.
Because they're protected by another super intelligent machine called the corporation.
Mark Zuckerberg.
Right. Yeah. So I think we're probably, we may have to see a much bigger, more obvious catastrophe before the world really pays attention. Just, as with, it took Chernobyl for people to take seriously the idea that, yes, nuclear power stations really can explode.
Yeah. So, but maybe we'll get a disaster, maybe not. But whether or not we have a disaster, you actually have a novel solution, or at least a proposal for a new approach, which, in retrospect, which I think is true of the best solutions, seems sort of obvious. Essentially, to have the AI be constantly beholden to a human intelligence, essentially to find out what it is that we want, what is good for humans. If that's a very poor summary, please take the mic.
Okay, well, yeah, so if it's not possible to specify the objective completely and correctly, then the machine had better not assume that it has the complete and correct objective,
right?
Obviously, right? So in other words, it knows that it doesn't know what the objective is. So the main thing is to sort of think of like, okay, where's the objective? And in the standard model of AI, it gets plugged into the machine's head. Now it's in the machine.
Someone literally writes, "This is the objective," and it is defined thusly.
I mean, if you get in a self-driving car, you'll type or speak the objective, or you take out your ride-hailing app.
Right.
You type in the address you want to go to. That becomes the objective of the algorithm, and so on. It's a very natural thing. But in fact, the objectives are really in us, right? It's what we want the future to be like. And in most cases, it's not even explicit. It's not available to introspection. A lot of the time, you never even thought about it, right? I mean, I bet most of you have never thought, would you be happier if the sky was olive green instead of blue? Right? I bet you never thought about that. But if a machine made the sky olive green as part of its climate control efforts, you'd probably be a bit upset, right? So there's tons of stuff that is implicit in our preferences, and there's a bunch of stuff we literally don't know because we never tasted a particular kind of food, and we just don't know our own preferences about the future epistemically. So the objectives are in us, and the machine knows that it doesn't know what they are, but it's obligated. So basically, we design the algorithms so that the machine is obligated to try to optimize the human preferences. So there's a field that's called game theory, because now there are two entities here. There's not just a machine pursuing its objectives. There's a machine trying to optimize objectives that are in the humans. And so
it has to guess at those objectives. It doesn't know them.
It doesn't know them. And so this becomes a kind of a two-person, or in general, right, there's going to be billions of machines and billions of humans. But so game theory handles those problems. And so what we're arguing basically is if you formulate the problem this way, then when the machine solves it, the better it solves it, the better the results are for human beings, as opposed to the standard model where the better the machine solves the problem, the worse the results are for human beings. And I don't want to say, okay, great, that's done. I'm selling my trillion-dollar corporation tomorrow.
Right, good.
Maybe next year. But there's a lot of work that needs to be done to make this happen in reality. To replace, basically, I have to go through the textbook on AI and replace every single chapter, right? All of the algorithms that we've developed, the techniques, the theorems, with new algorithms, techniques, and theorems that handle the fact that the machine doesn't know what the objective is.
So is this something where we really have to start from scratch, or do you expect that the standard model will still be useful in ordinary situations, limited situations where you don't need to worry about a superintelligence emerging, you just want it to make the coffee? We have a coffee making machine in the back right now, a little coffee making robot. It doesn't seem like it's going to take over the world, but I haven't written a book about it.
I think there are plenty of situations where you don't need general purpose intelligence, and you can be fairly sure that it's safe because you give it a limited scope of action, right? So, for example, if you design a program for playing chess, so when humans play chess, you might think that they win by playing good moves.
I don't.
No. They win by trying to distract the opponent by fidgeting or coughing, or some have actually tried to hypnotize their opponent.
Wow. Okay.
They bribe the referee. They kidnap people's relatives.
Well, that I've tried.
Right? So they do all these kinds of things, but that's because they're not stupid, right? They realize that there's more to the world than just moving pawns and knights on the board, right? But you can make a program that literally cannot do anything but move pawns and knights on the board. So you might think, okay, that's fairly safe. But now imagine a Go program, right? And all it's allowed to do is put stones on the board. But if it's really, really intelligent, it might think to itself, okay, just as we do, well, how am I here, right? What is this universe that I'm operating in? How does my brain work? How does the physics of the universe work to support my brain? So those are perfectly reasonable questions for an intelligent entity to ask, because after all, we are human and we asked it, right?
Yeah.
I mean, I imagine that cockroaches are probably not asking those questions, but we are, and presumably something super intelligent would ask that as well. Well, it's still only, its universe appears to be accessible only through playing moves on the Go board, but it would figure out, well, okay, I'm computing, so there must be some physical substrate that's producing my computational behavior.
I compute, therefore I exist.
Yeah, exactly. There's something else playing the moves, the black stones, if I'm playing the white stones. Let me try to figure this out, right? And eventually, it would start playing moves in patterns to try to communicate with the other entities that it must be out there.
Spelling out help, I'm stuck inside a Go game.
Yeah. Right? So it's very hard to prove that it can't escape if it's sufficiently intelligent. But there's no risk from completely dumb programs. The problem is if you wanted to have, for example, a domestic robot that has enough common sense to run your household successfully, with all the weird kind of stuff that happens in households, it has to be pretty intelligent, right? It's not going to be useful if it's stupid enough to, cook the cat for dinner.
Oh, yes.
Or something like that, right? So the companies would just go out of business immediately if that kind of thing were to happen.
So we only have a little bit of time left, but I wanted to ask, one thing I really enjoyed about your book is you really reached into the past to get some of these older authorities. And like you mentioned, of course, Turing, mentioned this problem early on, Norbert Wiener. And even you went back even further to people like Samuel Butler's Erewhon, and even going back to like Epicurus and stuff. Yep. I thought it was fascinating that you were reaching so far back to inform a present idea about AI. Do you think that people creating AI today don't have a broad enough base of to make these kinds of large decisions?
Yeah. How can I put this politely?
I didn't ask it politely. So.
No, they don't. I mean, it's a trend that many commentators have observed that present-day research papers typically cite nothing before 2014. And you'll see leading luminaries in the deep learning community talk about the possibility that they might need systems to do things like reasoning, as if no one has ever thought of that before, right? As if Aristotle didn't exist, and Quine didn't exist, and all the rest, right? So there's a massive amount of stuff that we already know how to do that I would say a lot of the modern AI community has completely forgotten. And they're going to have to reinvent very painfully and slowly. And I would say that, to be honest, the traditional AI community went through a lot of that reinvention because we didn't know probability theory very well for most of the period and so on. So this isn't a new thing, but I think it's much more extreme now.
Well, we have to.
Let me just want to mention.
Go for it.
I want to mention one thing, right? So earlier, Devin asked me, is there one thing you would recommend that the audience read? Because it's free, besides the book.
Yes.
Because it's free, you can download it right now. It's called The Machine Stops.
By E.M. Forrester, and I've read it, and it's really, really, really interesting. Written in 1909, right?
Yeah, so it's written in 1909, and it's not about this particular problem, it's about the next problem. So assuming that we don't destroy ourselves by creating out-of-control machines and so on, it's the problem of overuse of AI. So the fact that once AI is capable of running our civilization, we no longer need to teach the next generation everything we know about our civilization. Right? The incentive to go through what has been up to now, roughly 1 trillion person years of teaching and learning, just to keep our civilization going. When that incentive disappears, it's very hard to keep civilization in human hands. So it's an amazing story, amazingly prescient. It has the internet, it has MOOCs, it has iPads, video conferencing, computer-induced obesity, you name it.
Oh, yes.
He thought of it.
So, well, thank you for the recommendation, and thank you for joining us today. This has been extremely fascinating. You'll be doing a book signing and selling outside at about 11:30, right out by registration. So hopefully we'll see some of you guys out there.
Okay, thank you very much.
Thank you very much.